Hi, this is Kunal. I am a chemistry educator for more than 10 years. I have successfully mentored many students for IIT JEE and NEET. I have also got opportunities to work with many leading organizations of India. Today, I would like to discuss a very small topic related to organic chemistry, that is of Grignard reagent. As we know that the chemistry of carbonyl compounds is quite significant in organic chemistry, and Grignard reagent has multiple range of reactions with these compounds. Grignard reagent has a significant role in JE and NEET also. So let's begin the topic. So Grignard reagent can be written as RMGX, where R stands for an alkyl or aryl group. X is here a halogen atom, preferably iodine, bromine, or chlorine. Fluorine is prohibited as RMGF is relatively unstable. Why it is unstable, we will discuss later in this video. Now, this one is an organometallic compound. Grignard reagent is termed as an organometallic compound. Organometallic means compounds having carbon metal bond. As we know that electronegativity of carbon is higher than that of metal. So when there is any electronegativity difference between two bonded atoms, the bond becomes polar. Polar means a partial charge develops on either of the atoms. The more electronegative atom bears a negative charge as the bonded electrons slightly shift towards the more electronegative atom, and the metal being electropositive or less electronegative bears a partial positive charge. So we can say that the Grignard reagent acts as R minus or Carbanion donor. R minus in reactions. Now this R minus can act as a base or a nucleophile. The base has a tendency to capture acidic hydrogen from the substrate, captures acidic hydrogen from substrate. The nucleophile donates a pair of electrons to atoms or sites other than hydrogen in substrate. Again, we will see both the types of reactions of Grignard reagent, that is acid-base reaction and nucleophilic addition reaction. Now moving on to the preparation part. So a radical pathway is proposed, or free radical pathway is proposed, that is alkyl radical and halide free radicals are formed. That is, when Rx, that is alkyl halide is warmed in a mixture of magnesium and dry ether at 35 degrees Celsius, Grignard reagent is formed. Now what is the mechanism? Mechanism is quite simple. The Rx bond is first homolytically clipped on heating. This bond is homolytically clipped and we get the two free radicals. Now these free radicals combined with the valence electrons of magnesium. Magnesium has two valence electrons and thus RMgX bond is formed. Now considering the stability of X dot formed, it is Br dot I dot Cl dot and F dot. Here the stability of F dot is very low, or stability of fluoride free radical is very low due to its size. Fluorine has very small size and it has significant lone pair odd electron repulsions. While in case of iodine or bromine, the size being higher or bigger, this repulsion is low. So this one is relatively more stable and this one is less stable. Hence, formation of RMGF is prohibited. Now, moving on to stereochemistry of this reaction. Stereochemistry of formation of Grignard's reagent. As we know that free radical alkyl radical is formed, then it significantly affects the stereochemistry of the reaction. That is, suppose we have R dot, free radical. Now moving on to its structure, we know that it is odd electron in p orbital. It is sp2 hybridized. So when we consider an optically active optically active alkyl halide, and we warm it in a mixture of dry ether. Then first of all we will get an alkyl radical like this: methyl, ethyl, hydrogen, and of course Br radical. Now the magnesium having two valence electrons, one will combine with Br dot, and here we have two possibilities. It can attack from the front end or it may attack from the rear end. Now let's understand. Suppose this one is the plane containing methyl, ethyl and hydrogen molecules or atoms, and this one is the p orbital. This is frontal lobe and this one is the rear lobe, that is the lobe lying below the plane of the molecule. So magnesium can attack from the front side as well as from the back side. Frontal attack results in retention of configuration in terms of RS, and a rear attack may result in or results in inversion of configuration. So we get two products here, as there are two possibilities. One will be like this: Me, Et, MgBr, and here hydrogen, and the other will be like Me, Et, MgBr and hydrogen. So either with respect, here hydrogen lies on the same side, so this one is retention of configuration. Here hydrogen moves to opposite side, so this one is inversion of configuration at the asymmetric center. Or suppose this one is D isomer, so this one will be the L isomer, and the amounts are equal, that is 50% of D and 50% of L, and when equal amounts of D and L isomers are present, we term it as a racemic mixture, which is optically inactive, or a DL pair. So conclusion is that whenever we have NRX having an asymmetric center and we warm it with magnesium and dry ether mixture, we get RMGX. This one is a DL pair. Sometimes we could have more than one asymmetric centers in the RX, like and we warm it with magnesium, dry ether and heat. So we get two products. One will be like this. This one is retention of configuration and the other will be inversion with inversion of configuration or a DL pair. No, this one is not a DL pair. Sorry, these are not mirror images, and optically active compounds which are not mirror images are termed as diastereomers. So in case of Rx having C star 2, we are getting a pair of diastereomers. So this was all about the stereochemistry of the reaction. Now we haven't discussed the role of dry ether. So dry ether, it is significant. Dry conditions due to capture of H plus ion from moisture. If any of moisture is present in the reaction environment, then Grignard reagent is not formed. It captures the moisture, that is H plus from the moisture, and alkane is formed. So Grignard reagent is reduced here. So we will not obtain Grignard reagent. We will obtain instead alkane. So dry conditions should be there. Again, ether acts as a solvent, that is polar solvent, aprotic solvent. Aprotic means it cannot release H plus ions. And it retards the rate of reaction of Grignard reagent. That is, suppose we have an ether, the reaction of Grignard reagent is vigorous, so dry conditions are taken. It bears partial negative, negative, and it bears partial positive charge. Oxygen has partial negative charge, partial negative charge. So during the formation of Grignard reagent, the oxygen atoms of ether molecule combines, as we can roughly say that, attracts the magnesium ion and retards the rate of reaction so that vigorous reaction does not take place. So let's keep our lecture confined to this much. Later we will discuss the reactivity of Grignard reagent as acid-base reaction or as a nucleophile in carbonyl compounds. Thank you.